You may ask, can we do three-part or even more if-else statement with if-else function? That's the concentration of activity 5. Activity 5 asks us to repeat activity 3, but this time with if-else function. Okay, activity 3. Activity 3 is this. Write a code in R that gets two input of x and y. Then if x is greater than y, it prints the message of x is greater than y. If they are equal, it says they are equal, and otherwise it says it is smaller. So you see there are three parts. And if we check the structure of if else, at the first look, you have only two conditions. So I guess it can give you a very good challenge. And so please, before you check the answer um, in the following moments of the video, try your best to do it yourself. So it is if else, you have condition, and if it is true, and not here if it is true. But as you just noticed here, it wants you to cover three statements on conditional state. So think about that and see how you can do it before you check the video. Now I'm in RStudio environment, and here the code that we had regarding activity 3. So we are going to make the same code but with different structure, that is if else. Okay, so I'm going to do it if else. First, I need to put the condition. What is the condition? The condition is x greater than y. So I put the condition, if x greater than y, then it should return this one. X is greater than y. So I put it here. But if not, let's see what should we put here, because it checks if x is greater than y, then print this. Otherwise, do what? Otherwise, again check. We put another if else here. What is the another things that we need to check? X equal to y. So I put x equal to y. So you see, if it checks if x is greater than y, then it prints x is greater than y. But if it is not greater than y, so it checks if it is equal to y. Okay, when it checks if it is equal to y, if it is correct, if it is true, so it should print this one. See how much this function is efficient. Print this one if it is true. If it is not equal to y, and we already know that it is not also greater than y, so of course it is smaller, so it goes to the else situation. We can put as many as necessary as else if statement with if else function. So I put it here. So I'm done now. I can give the values and try our code that we finished it in one line. So x, just put 7, and y, put 9. And we are gonna run these 3 lines and check the answer. Okay, when x is 7 and 9, see it says x is smaller than y. I'm gonna change x to 9 and run it. Oh, so we are gonna get all of them and to see if it works properly. And you see, in this situation, it says x and y are equal, and as the last one, it is 11. And I run it, and it says x is greater than y. So it was the answer to activity 5. After if statement, it would be good to cover together some useful functions in R. The first one that we are going to review is percent in percent, as you can see. And similar to the other commands and functions in R, what it does is very close to its name. So when you see in, it checks presence of something in another thing. Let's check them together, and we are going to practice on them, and you are going to get it completely. To identify if an element, for example, a number, belongs to a vector or data frame. Okay, so when you want to see if something is present in another things, you can use this. For example, if you have, I'm just write it mathematically. For example, you have A, B, C, E. Okay, when you want to see, for example, if an element is in this array, in R, you do it in this way. For example, what is the element you want to check if it is inside this array? For example, it is X. So you check X percentage in percentage. And what is the name of this array? We put it M. So it checks if X is inside M. And the result could be true or false. That in this case, since we don't have X in this array, it is going to be false. That much simple. And again, the logic that we mentioned about mathematical computations in R applies here. So let's read it together so you understand it better. To identify if an element, for example, X, or a number or anything, belongs to a vector or data frame. It can compare vectors of different lengths to see if elements of one vector match at least one element in another. The length of output will be equal to the length of the vector being compared, the first one. Makes sense, my friend, because you want to check if something belongs to another thing. So it tells you based on the question. For example, when you check if X belongs to M, what would be the answer? True or false? Why? Because you are putting one item here, and it tells you, and it just needs to give you one true and false. But if you put here, for example, if you put here something like this, X and C, okay, belong to M. What would be the answer? X is not in the array, so it would be false, but C is in the array, so it would be true. So that's the logic behind the point that it says. It can compare vectors of different lengths. So you see, vectors. We can compare even vectors of different lengths to see if elements of one vector match at least one element in another. The another is M here, and the other one is the first one. The length of output, that is here, will be equal to the length of the vector being compared. This one. That is the first one. Okay, here, before we start doing this on RStudio, it says W34, that is the name of the vector, is 25375. And W35 is a vector of this sequence from 1 to 10. Now here it checks if W34 belongs to W35. First question, what is the length of the results? The length of the results is the same as the first one, the one that is being compared. That is mean it is W34. So it checks if this belongs to this. I'm asking you, 2 belongs to 1 to 10? Yes, it is true. 5 belongs to 1 to 10? True. 3 true. 7 true. 5 true. So you see here, 5 true, because all of them belong to that range. Another one, it says W34, the same one as we had it here, but W35 now 5 is now a vector that is a sequence of numbers from 1 to 4. Okay, so it checks based on the vector that is being compared. Okay, it checks if 2 belongs to this range. 2 belongs to range of 1 to 4. Yes. 5 belongs to range of 1 to 4. No. 3 belongs to 7. False. 5 false. So you see here, these are the results. This function in is very helpful with many examples. And if we get time at the end, I'm going to give you some sort of project type programming that you need to use this type of things to be able to get the answer. Okay, now let's go and do this stuff in RStudio to check the results. Okay, I'm going to make the vector that I want to compare, and I'm going to name it A 2 5 7 8. And after that, I'm going to make B, and I'm going to make it another vector. That's it. Okay, we have this. We have this. Now I write this one. I'm checking if 6 belongs to A, and I run it. As you can see here, 6 in A, it is false. What happened here? It is the code I write, and it checks 6 is not belonging to these things. I change it to 2. 2 belongs to A, and we know that it is true. So it is the answer. And what happens if we check it in this way? See, we have 6 and we have 2, and it checks it in A. And the first one, 6, is in A, it is false, and the other one is true. Let's try and make it a little bit more challenging for R. And here I'm going to put, for example, CF. Remember, the vector cannot get different types. So by default, it's gonna change it. Okay. So then I get the structure of A okay, you see all of them are character. So in fact, consider all of them as character just to avoid an error message. And as the last point, you see I'm checking if CF is in A, it gives me true. And when I put 6 in A, it gives me